Alright, so when we look through this review, remember anytime that I'm having to deal with a graph and different characteristics, one thing that I can always do is type these problems into Desmos and see what's happening. I could also use the table function on my calculator. With a button, you press table, you type in the function, and then go through and find all the things. This first problem is in vertex form. You can find that on your formula sheet. And because the 4 is inside the parentheses, that's going to be my h value. I know that it's lying, so I know that the x value of my vertex, or the h, will be -4, while the k value will be +1. I also know that the domain of every single quadratic function, no matter what, as soon as I see x squared, that the domain is going to be -infinity to +infinity. Now, to determine the range, max or min, I want to look at the a value of this problem, which is out in front of my parentheses. It's not written there, but I know that there's an implied 1. And because 1 is a positive number, it's going to tell me that this problem is concave up. If it's concave up, it means that the vertex is going to be a minimum, and that my range will go from 1 to infinity. Remember, 1 gets a bracket, infinity gets a parenthesis. Our axis of symmetry is always the x value of our vertex, so you'll list here x equals -4. To find the roots, we're going to need to look at the graph and have an xy chart. So now that we know what our vertex is, -4, 1, I want to put -4 in the middle of a table and build my x values around this. So I'm going to use -3, -2, and then I'm also going to use -5 and -6. What you'll do is take your calculator, plug these things in. We should get 2 here, and for 6, we should get 5, and we should get 2 and 5 again. Then when you come to graph these points, you will have -4, 1, -5, 2, -6, 5, and this is what our graph should look like. We can see that this does not touch the x-axis anywhere, so we can say that there are no roots. Remember, if it does have roots, we would list as a coordinate pair what those roots are. For number 2, as we're getting ready to solve this, we need to start by listing our a, b, and c values. So a is -1. Notice there is no x, so b will be 0, and c will equal -2. That's important because this problem is in standard form, and in order to find the vertex, if I'm not putting it in Desmos or in my calculator hitting the table function, is to use -b over 2a. So -b divided by 2 times a, b is 0, 2 times -1. That's just going to give me 0. That's my x value of the vertex. And then the way to find the y value of the vertex is to plug that in. So you have negative times 0 squared minus 2. That means the y value of the vertex will be -2. Remember, domain will never change. So that's going to be -infinity to +infinity. My range here, we have to be careful. My a value is negative, which means this is going to be concave down, which means that my vertex is a maximum. So I will go from -infinity all the way up to -2. My axis of symmetry is always going to be the x value of the vertex, so x equals 0. We create an xy chart to go with this. 0 goes in the middle, 1, 2, -1, -2, and then we'll plug in these values. So if I plug in -2, that gives me -4 minus 2, which will give me -6. If I plug in -1, it's -1 minus 2, which gives me -3. Then we have 0, -2. We've already found that from our vertex. When we plug in 1, we'll get -3. We plug in 2, well, we should get -6. Again, you can use Desmos or the table function from your calculator. Either way, you'll get the correct answers here. So we have 0, -2, 1, -3, 2, -6, And then -1, -3, -2, -6. Yet again, we have no roots because my quadratic function does not touch the x-intercept, the x-axis at all. Number 3 is still in vertex form. That's from the formula sheet, so I can tell that the value inside the parentheses is lying. It's not -3, it's +3. And then the k value, which is outside the parentheses, is telling the truth. Yet again, you could type this into Desmos and just look for the answer. The domain of any quadratic function that you're ever going to see, -infinity to +infinity. My a value here is -2, which is going to tell me that this is concave down, meaning that my vertex is a maximum. That's going to help me with my range. That means I will go from -infinity all the way up to +5. My axis of symmetry, please remember, is always the x value of your vertex. So x will equal 3. And then for roots, we're going to have to fill in the xy chart to go with it. 3, 5 would go in the middle. That's my vertex. I want to be able to see both sides of the parabola. So 3, 2, 1, and 3, 4, 5. Then we plug this in to what we see. So if we plug in a 1, we get -3. If we plug in a 2, we get 3. 4 should give us 3. And 5 should give us -3. And all you're doing is typing these things either into Desmos using the settings wheel to get the chart and looking for these values, or putting them into the calculator, completely up to you. We're going to graph these values. So 3, 5 is my highest point. Then we had 4, 3, and 5, -3, and then 2, 3, and 2, 3, and 1, -3. We can see that this does touch our x-axis twice. So we have 2 roots, and those 2 roots are, it's not going to be perfect, maybe 1.50, remember, as coordinate pairs, and then also 4.50. If you don't want to create a chart, remember you can go to Desmos and work this out. Number 4 is also going to be in vertex form. We can see that because of the parentheses. The 6 is inside the parentheses, meaning it's telling us a lie. So the h value, or the x of the vertex, is -6. We don't see plus or minus anything, so my k value is 0. The domain is always going to be -infinity to +infinity. We can tell the concavity based on our a value here, which is 4, meaning it's going to be concave up, and that our vertex is a minimum. Axis of symmetry is always the x value of the vertex. So because this point is a minimum, my range will start at 0 with a bracket and go up to infinity. Create our xy chart. That means -6 is going to go in the middle. We go -5, -4, and then -7, -8. Then we're going to find the y values that go with this. If we plug in a -8, 4 times 4 is 16. Remember, -8 plus 6 gives me -2. -2 squared is 4. If I plug in a -7, that would give me 4. If I plug in a -6, I would get 0. -5 will give me 4. And -4 will give me 16. As I get ready to graph these, -6, 0. -5, 4. And then I won't be able to graph -4, 16. It'll be off my graph. So I come over to -7, go to 4. So I can tell that this will be what my quadratic looks like. My vertex in this case is sitting on the x-axis. So this will have one root, and that root will be the vertex. Moving right along, we have another problem that is in vertex form. So I can go ahead and answer that pretty quickly. The h, or x value of the vertex, is inside the parentheses, so it's line. It's not -2, it's +2. -7 is my k value, so that's my vertex. Domain is going to be the same, and no matter what type of exponential function, or what type of quadratic function we're looking at, -infinity to +infinity. Our a value here is +1/2, which tells me to be concave up in a minimum. My axis of symmetry, x will equal 2. For my range, because this is a minimum, it'll start at -7, and that should be a bracket, and then go all the way up to infinity. For our roots, we're just going to fill in our values. We go 2, 3, 4, 2, 1, 0, plug these things in. If I plug in a 0, I get 2 minus 7, which is -5. Plug in a 1. So that would give me 1/2 minus 7, which is -6.5. I plug in a 2, I get -7. 3 will give me -6.5, and 4, -5. Then we're just going to plot these same points. So the vertex is at 2, -7. At 3, we have -6.5, which would be about right there. And then at 4, -5. We could see this all the way through. This will eventually touch. We'll have 2 roots, and then you'll just use Desmos to estimate where those 2 roots are. Where is the y value equal to 0? So where does it touch the x-axis? For the next problem, we've got to use -b/2a. This is in standard form. Well, my a value is -4/3. My b is equal to 0, and my c is equal to 0. So if I plug in to -b divided by 2a, that means I've got 0 divided by -4/3 times 2. That's going to give me a 0. And when I plug a 0 in, it'll also give me an answer of 0. The domain is always -infinity to +infinity. My range on this one, this is going to be concave down. So for my range, it'll be -infinity to 0. Remember, -infinity always gets the parentheses. This is going to be a maximum because it is concave down. My axis of symmetry is going to be equal to 0. For my roots, we'll have to make our XY chart to be able to graph this. So 0 will go in the middle of my chart. We go 1, 2, -1, -2. So if I plug in a -2 here, -2 squared gives me 4. That gives me -16/3. It's going to be pretty hard to graph. If I plug in a -1, that'll give me -4/3. If I plug in a 0, I get 0. 1, I'll have -4/3 again. And 2, I'll have -16/3. So we're just going to use some estimation. You can use Desmos to help you with this. My vertex is going to be at 0, 0. When I go to -1, that's -4/3, or -1.33. So maybe about right here. And then -16/3 is going to be -5.33. So maybe here. And then we'll graph the same thing as we go through. In this case, we're only going to have one root, and that happens to be the vertex that is sitting at 0, 0. Moving to the next page, they are asking me to list all the characteristics of this quadratic. Remember, domain is always -infinity to infinity. The range, what is the lowest y value on the graph, will be -4 up to infinity. the vertex right here to -4. Our axis of symmetry is always the x value of the vertex, so x equals 2. We have two x-intercepts, coordinate pairs 0, 0, and 4, 0. My y-intercept, there's only one. Where does this touch the y-axis? And that is at 0, 0. This problem is increasing. Remember, we use x values only from 2 to infinity. This problem is decreasing. X values only, reading the graph left to right, from -infinity to 2. It's positive, which means above the x-axis in two places. That is from -infinity to 0, and also from 4 to 0. This only has one negative section, and that comes from 0 to 4. The direction that this is opening. That means it's concavity. That just means that it's concave up because it is opening up. This graph does have a straight line, which means it is continuous. It's connected. Every point is connected. Our end behavior, as x is approaching -infinity, y is approaching infinity, meaning the left side arrow is going up. As x approaches positive infinity, y is also approaching infinity. On the right side, which direction is the arrow pointing? That's up. Is this a function? Yes, it is. It passes the straight line test. And is there a maximum or a minimum? And if so, where? Well, this is going to have a minimum, and it's going to be at the vertex, and that vertex is to -4. Okay. The next question is asking us to compare two functions to each other. So I have a quadratic and I have a linear function, x squared plus 2 and 3x. It's advising us to create two tables to see what's happening. So we'll call x squared plus 2 this first table. And the second table, 3x, we'll make over here. And we're going to combine or look at different values of these things. So let's use -2, -1, 0, 1, and 2 in both tables. -2 squared is 4, plus 2 is 6. -1 squared is 1 plus 2, which is 3. 0 plus 2. 1 plus 2, which is 3. And 4 plus 2, which is 6. For 3x, we're going to use the exact same values, -2, -1, 0, 1, and 2. We're going to plug these things in. 3 times -2 is -6. 3 times -1, -1. 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. So for what x values are f of x and g of x the same? So we're just looking for the exact same values in the chart. And we can see that there's 2 points where these things are the exact same. We have -2, 6, -2, 6. We have -1, 3. Oh, that's not the same. Don't make the same mistake that I just did. I tried to make -1, +3, and -1, -3 the same. Remember, those are not. But we also have 1, 3, and 1, 3, and 2, 6, and 2, 6. And so you would just list where these things are the same by telling all these pieces. Oh, go back. I also made a mistake here. This is not the same. 2, +6, and 2, -6. So please be careful not to make that same mistake. Don't get it in a hurry that I just did. We only have 2 values where these are the exact same, and that is 1, 3, and 2, 6. Which has a larger average rate of change from 3 to 5? Remember, this is where we go to our formula sheet. You find the slope formula, which is y2 minus y1 divided by x2 minus x1. And they give us our x values. So for the f of x problem, They're telling me my x values are 5 and negative 3. I'm going to have to find the y values that go with this. So if I plug in a 5 to x squared plus 2, 5 squared is 25, plus 2 is 27. And then I'm going to plug a 3 in. 3 squared is 9, plus 2 is 11. You put this in the calculator and you'll simplify. You get 16 divided by 2, which is 8. And then we're going to do the exact same thing for our g of x equation, which is 3x. So we're still going to use 5 and 3 as our x values. 5 times 3 is 15. 3 times 3 is 9. We subtract, we get 6 divided by 2, which is 3. So which one of these is larger? That would be f of x, this equation here. Now they're giving us a graph. I'm going to ask questions about the two different functions. Make sure that you can make a note of which function is what. The green function here is f of x, that's exponential. The blue function, g of x, is quadratic. So for which values is f of x greater than g of x? And so if you see here, g of x is below f of x in this first section. The g of x line is below f of x, so that makes f of x greater. And then there's another section where f of x is on top of g of x, or greater, and that's from these values. So f of x being greater than g of x, this should say the only option that works here is D. Now, even though it's always out here at x equals 4, it's still going to be greater from those points. Number 10 is asking us to find the slope. So we're going back to our formula. y2 minus y1 over x2 minus x1 is giving me my x values. So 20 minus 5. And then we just look in the chart. The value that goes with x equals 20 is 43. The value that goes with x equals 5 is 3. You put this into your calculator. So we have 40 divided by 15. You are welcome to leave this as a fraction as long as you simplify. 5 can go into both of these, so we'll leave it 8 over 3. Or if you prefer the decimal, you would turn this into 2.67. Either answer will work. It's completely up to how you want to leave it. More values here. If I'm given the function, we want to make sure that we can find all of these different values. So you would plug this into Desmos and find each of these. So if we have negative 5 halves times x minus 6 squared plus 10, we see that's in vertex form. The first question that they're asking me is the domain. Without thinking, you should know that that is negative infinity to infinity. Now for our range, we have to be careful. This is going to be concave down because of the negative 5 halves. And our vertex, even though it hasn't asked it yet, it's down here later in the question, can be taken right out of the equation. Remember, the negative 6 is line, it's inside parentheses. So it's a positive 6, the 10 is on the outside, and it's positive, so it will stay there. So for my range, because I know this is concave down, I know that the highest point on the y for my y values will be 10, and my lowest point will be negative infinity. And again, you can type all of this into Desmos and help you find these answers. For my interval of increase, where is this graph going to be going up? From negative infinity to 6. Remember, we're using x values only. Interval of decrease will be 6 to infinity. X values only. So for your positive intervals and your negative intervals, this is where you'll want to look at your graph. I'm going to skip these two for right now and go down to the parts that we already have answered. Our vertex, we said, was 610. The x value of the vertex is 6. We've also said that this is a maximum, and that is going to be at the point 610. For our end behavior, as we look at the left side, that is as x is negative infinity, so the left side of the graph, y is going to negative infinity. As x goes to positive infinity, y is also going to go to negative infinity. Both sides of this graph are doing the exact same thing. They're both going down to negative infinity. For your intercepts, this will be where you just go back into Desmos. Tell me where it touches the x-axis, where it touches the y. Same thing for your positive intervals and your negative intervals. So just make sure that you're using Desmos. You can also check the answer key that is posted to find these correct answers. For this next one, plug it into Desmos yet again. We can tell that this graph is going to be concave up. X times x is x squared times 4, which is going to be positive. So right away, we can already say that this is going to be a minimum. Down here. The domain will never change. It's an easy one, negative infinity to infinity. For the rest of this, all that we're going to want to do is plug this into Desmos and see what happens. Our axis of symmetry to here will be at x equals negative 1. Our vertex will be negative 1. You'll have to just plug that into Desmos and see as we go through. Intervals of increase and decrease. Remember going through and looking this on Desmos, our interval of increase will be from negative 1 to infinity, x values only. Interval of decrease will be negative infinity to negative 1, x values only. Our end behavior, both of the ends of this function are going up towards positive infinity. X-intercepts, look at Desmos, see where this is touching the x-axis. Y-intercept, look at Desmos, see where it's touching the y-axis. Again, you can check the answer key that's posted to make sure you get the correct answers. Each of these problems are given to us in vertex form. Remember, that is given to you on the formula sheet. And it wants us to write the answers in standard form. This is what we call the Nike problems, where all we want to do is just do the math that comes along with it. So we're going to start by expanding the problem. Negative times x plus 5 times x plus 5 plus 4. We like to distribute the negative first. So we have negative x minus 5 times x plus 5 plus 4. We're going to use the distributive property again. So negative x times x gives me negative x squared. Negative x times 5 gives me negative 5x. Negative 5x times x gives me negative 5x. Negative 5 times negative 5, negative 25. I haven't used the 4 that's in the problem, so I'm going to bring it down. And then to write our final answer, we just want to combine like terms. So negative x squared minus 10x minus 21. And that'll be our final answer. 25 is a little bit easier for us when we get ready to expand. We don't have an a value written out, it's just 1. So 1 times anything is going to be itself. So I can go ahead and jump straight into distributing my parentheses. X times x, x squared. X times negative 6, negative 6x. Negative 6 times x, negative 6x. Negative 6 times negative 6, positive 36. Haven't used the 8, so I bring it down. And then we just want to combine like terms. So our final answer will be x squared minus 12x plus 44. For 26, we do have the 8, so we need to include it. So it'll be 8 times x minus 1 times x minus 1 minus 7. We're going to start by distributing the 8, which will give us 8x minus 8 times x minus 1. We bring down the negative 7. Then we'll distribute. 8x times x gives us 8x squared. 8x times negative 1, negative 8x. Negative 8x times x, negative 8x. Negative 8 times negative 1, positive 8. Bring down the minus 7. Then we just want to combine our like terms. So we get 8x squared minus 16x plus 1. And do not let the fact that we have fractions intimidate us here. Remember, you have a calculator that will do the work for you. So you have negative 3/4 times x plus 10 times x plus 10 minus 3. We're going to start by distributing the negative 3/4. So we get negative 3/4 x plus 30 over 4. We could simplify this as we get to the end of our problem. Then we have times x plus 10 and minus 3. We're going to distribute negative 3/4 x squared minus 30. Oh, this should be a minus here as well. It is negative, sorry about that. Negative 3/4 x times positive 10 gives us negative 30 over 4 x. Negative 30 over 4x, or times x, gives us negative 30 over 4x. And then negative 30 over 4 times 10 gives us negative 300 over 4, and then bring down our minus 3. Again, we are going to simplify this. We're going to do that at the very end here. Combine our like terms. So we will get negative 3/4 x squared minus 60 over 4x minus 312 over 4. And the only problem with this is we need to go back and simplify our fractions. You can put this into the calculator or do the work for you. So we leave negative 3/4 x squared. 2 can go into both of these. 4 can actually go into both of these. So we have minus 15x, because 4 will go into 60 15 times. And then 4 will go into 312. Four will go into both of these things, so 4 will go into 31 7 times with 3 left over, which makes it 78. And again, the calculator will do all this work for you. If you type these things into the calculator, it will actually simplify for you earlier. Putting these things in vertex form, let's not forget what vertex form looks like. It's on the formula sheet. You do not have to have this memorized. So if they're giving me a vertex and a point, every single time we want to make sure we go through and label first. So h and k is my vertex, x and y is my point. So on every single one of these problems, that's what I'm going to do, is go ahead and start with h and k and x and y. So we're going to set it up using what we know. We have a y value, negative 4. Sorry, that's a 9. Negative 9 is going to equal a, we don't know what that is yet, times our x value, 3, minus negative 1, so minus h squared, minus k. First thing we have to do here is solve for our a value. So 3 minus negative 1 is going to give me 4, and 4 squared is 16. So I'm going to have 16a minus 25 is equal to negative 9. In order to solve for a, the first step we need to do is add 25 to each side. So we'll get 16 equals negative 16a. Divide each side by negative 16. So my a value will be negative 1. Final step is just to rewrite the problem. Remember, we want x and y to be in the equation. That's what makes it an equation. So y equals our a value, which was negative 1, times x minus h. So we've got minus negative 1, turns it into plus 1 squared, and then negative 25 for k. For 29, we are going to plug into what we know. And we're going to start with 6 equals our a value times 0 minus negative 1 squared plus 8. Well, when we get ready to simplify, we'll have 6 equals 1 squared is 1, so a plus 8. This will be a little bit easier to solve for a. We're going to subtract 8 from each side, and we get our a value is equal to negative 2. Plug in what we know. Remember, we want to leave x and y in the equation, so negative 2 times x plus 1, because it needs to lie to us, squared plus 8. And that'll be our final answer. We have our h and k. We're going through, doing the exact same thing that we've been doing for the last 2 problems. So my y value is 12. 12 equals a times negative 1 minus 4 squared minus 1 half. So we get 12 equals negative 1 minus 4 is going to give us negative 5. Negative 5 squared is 25. So 25a minus 1 half. Then you're going to add 1 half to each side. I'm going to go ahead and make that a fraction. You can put this in the calculator. It's going to be fine, just to help us out in just a second. So if we do 12.5, we can leave it as a decimal actually. 12.5 equals 25a. Then you're going to divide each side by 25. In order to find all these things, you just plug them into the calculator and go back and plug in the pieces that you know. Remember to leave x and y in the equation. Remember, you can check the answer key that's posted on Canvas as well to get the correct answer. Please go ahead and mark out 31, 32, 33. Those will not be on this test. Also mark out 35. It will not be on this test. 34 will, though, because we can find a vertex in our chart. Remember, the vertex is like our sandwich piece, the one that doesn't have a match. So if we look, we have negative 3 and negative 3, 0 and 0. So I know that my vertex will be here at 5, negative 4. So that means that's my h and my k. We can pick any values we want in order to find our a value. I'm just going to pick 3 and 0. As long as you don't pick the vertex, you'll be fine, and you can plug in chug to go there. If our y value is 0, we don't know our a. Our x is 3, h is 5, squared plus k. 3 minus 5 is negative 2. Negative 2 squared is 4. So we have 0 equals 4a minus 4. To solve this, we're going to add 4 to each side. So you get 4 is equal to 4a. Divide each side by 4. So a in this problem will equal 1. As we get ready to plug it in, we want to leave x and y in the equation. So you can write the 1, but you don't have to. X minus 5 squared minus 4. Remember, when you were determining the type of function based on the table, this is where we subtracted in class. How many times do you have to find the difference? So when you subtract, you're doing the second minus the first, the third minus the second, the fourth minus the third, and so on. So what we're going to do is take 28 and minus 32, and we get negative 4. Then we're going to do 24 minus 28, negative 4. 20 minus 24 gives me negative 4. And 16 minus 20 gives me negative 4. Now, this one we have to be careful of. Please, let's check our x values as well. Because notice the difference in our x's. 7 minus 5 is 2. 9 minus 7 is 2. 11 minus 9 is 2. 13 minus 11 is 2. Now, we did only subtract one time, which means that this would be a linear function. Remember, the degree of a linear function is 1. We only subtracted one time. Let's look at 37. 5 minus 2 is 3. 10 minus 5 is 5. 17 minus 10, 7. 26 minus 17 is 9. I can tell right away that this is not linear. I've subtracted one time, and none of the values have been the same. So we're going to subtract again. 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is 2. Because we subtracted 2 times here, we think about which type of function has a degree of 2, and those are our quadratics. If we go back and check our x values, everything has a difference of 1. Finally, for the last one, we want to go through and subtract. 7 minus 3 is 4. 19 minus 7 is 12. 55 minus 19 is 36. 163 minus 55 is 108. So if we subtract these again, 12 minus 4 is 8. 36 minus 12 is 24. 108 minus 36 gives us 72. Because all of these have been different, we can tell that this is an exponential function. Identify the x and y intercept of each of these things. You are going to want to use our best friend Desmos for each of these. You can go in and check the answer key, but again, for each of these things, just plug this into Desmos so that you can find the vertex and the y-intercept. Okay, evaluate the functions that are given. All you're going to do is plug in the value that's given to us. So we have parentheses. Please put the values in parentheses that they're asking us to find so that we can put them in the calculator and get a correct answer. So this is how you would type this into the calculator. -6 minus 7, that's going to give us a -13. Squared is 169 plus 4 will give us a 173. For this next one, please again use parentheses. We have 5 times 4 squared minus 2 times 4 plus 1. Put this in the calculator and then find your answer. Same thing for each of these. Using parentheses, you're going to type this into the calculator. Yes, you have to do some of the work here. -10 times -1 squared plus 13 times -1 minus 3. You're just typing each of these things into the calculator as you go through. Okay, 3 times -2 squared minus 4 times -2 minus 9. Then we have 5 times 9 minus 3 times 9 minus 2. And again, put that in the calculator so you can find your answer there. 2 times 3 plus 3 squared minus 5. 2 times 0 squared plus 7. Then we have negative times -10 plus 2 times -10 minus 15. Finally, we have -8 squared plus 7 times -8 plus 10. Then we have our word problems. The word problems are really trying to help us know how to answer each of these things, so we're just looking for key terms. So the equation is given here as the height in feet of a ball thrown in the air as a function of time in seconds. At what time does the ball reach its maximum height? That just means find the vertex. And because it says height, it means to find the k value of the vertex. Nope, it does not say that. It says to find the time that it gets there, which means I am finding the h value of the vertex. which means I can type this into Desmos and find the answer, or you can list out your A, B, and C values. So if A is negative 16, B is equal to 40, C is going to be equal to 0 here. We use negative B over 2A as our formula. So negative times 40 divided by 2 times negative 16. Put that into your calculator. You're going to get 40 over 32. And then you just want to reduce that because you can put that in the calculator. It can be simplified. So if we say 4 will go in each of these, that's 10 over 8. 2 can go to both of those. So that'll turn into 5 over 4. So 5 over 4 seconds, or you can say 1.25 seconds. How do you find the y value of this? If you haven't plugged it into Desmos to find it, then you will take 1.25 and plug it back into the equation using our calculator like we just did on the problems before. Negative 16 times 1.25 squared plus 40 times 1.25. And then you would just hit enter in the calculator and make sure that you have feet given there. Then we have a barber's profit that's measured in money each week, and it depends on how much he charges per haircut. His profit can be modeled by this equation. How much should he charge per haircut to achieve a maximum profit? So what this means is we see the word maximum. We're looking for the vertex. How much should he charge? Well, how much he charges is the x value of our vertex. So yet again, we're going to use negative b over 2a. Our a value here is negative 200. My b value is 2400. And my c is negative 4700. So we'll type in negative 2400 divided by 2 times 200. 2 times negative 200, making sure that I can read my own handwriting here. So when you do this, you will get that he should charge $6 per haircut. And if he charges $6 per haircut, how much can he expect to earn per week? Well, this is where you come and you plug in that 6 anywhere you see the variable. It's going to look like this. And then all you have to do is hit enter into the calculator. And that'll be the amount of money that he can expect to earn per week. For this last section that you see here, find the vertex and the y-intercept. You want to go into Desmos, type in each of the equations, and then make a list of your vertex and y-intercept.